Okay. So let's build another step of our application stack. You know, in this course we are focusing mainly, we'll be focusing mainly in the next weeks on the front end of a web application, so on the browser with the interaction with the web page and so on. But every website, of course, needs to have some storage or some interaction with the server that keeps the persistence, or keeps the data, and implements all the APIs that the front end needs to interact with. Okay. So we will spend a bit of time in having a look at a very simple way of implementing a minimal server side for running our API code. And we'll do that with the one library in JavaScript, which is called, in this case, Express. It's a framework for web servers. Of course, the technology in which the front end runs and the technology in which the back end of a web application runs are totally independent. Okay, they can use different languages, different technologies, and so on. Of course, in the front end that runs in the browser can only use JavaScript, because JavaScript is the only language available inside the browser environment. On the server, you can do whatever you want. Just for the sake of not learning a new language, we just try to use one a JavaScript implementation of our server. Before that, I just want to recall some basic information about the HTTP protocol, which is the glue that connects the client with the server, and because we'll need some later on when we talk about the API implementation, we need to use the HTTP protocol in some way which is, let's say, not so conventional. Okay, I won't bore you again with all the network courses. Just remember that HTTP protocol is a client-server protocol where all exchanges are completed by a couple of messages, 2 messages. So every HTTP interaction is a client that sends a request message and a server that replies with a response message. That's it. After this interaction, the connection theoretically is closed. Then for efficiency reasons can be reused, but let's not get into that network details. Semantically, the connection is closed, and another HTTP request will be another request message followed by another response message. And all the interaction is always started from the client. Okay? The server cannot start an interaction or contact a client unless the client asks for something and the server replies. And the format of this message is very, very simple. They are text-based messages made of with the same format, with there's initial line with the command actually to deliver, some headers, which are the form of keyword colon value, and possibly a body in the request or a body in the response. And from the syntax point of view, what separates the headers from the body is an empty line. So it's a very, very simple format. The request is the command that the client asks the server to perform. In some cases, the command may involve some data in the body of the request or some information in the headers. And the response, of course, is the output of the operation, where the server returns maybe some information, maybe a web page, for example, the HTML code of web page in the response body, or some other information about error messages or how it went. Okay. So this is a very, very simple exchange method, and every request, there are just a handful of types of requests we can do, and they are called methods. Okay. So every HTTP request has a method, and normally 99% of the requests on the web are of type GET, are using the GET method, because GET is basically the only method that the browser uses when you're navigating around. because get asks the server to retrieve a resource, and the resource could be an image, could be a CSS file, could be a JavaScript file, could be an HTML file, and so on. Okay, so every time you click on something, 99% of the times the browser is sending a get command to the server that will host the content related to that link. It's not the only method. HTTP defines a handful of different methods, and here I put in boldface those that we are going to use in the rest of the course, where, and which we'll see next week, we are going to use the HTTP protocol not just for navigating web pages, which is what the browser is already able to do, but for calling remote operation on an API server from a client application. So we use HTTP was invented for browsing web pages, okay, but the methods defined in HTTP could be also used in a different way for interacting between two different applications. So most of the HTTP traffic that we will be implementing in our code will not be for delivering HTML code. It will be for, you know, getting the list of users or adding a new user or something like that. So between a client application, which runs on the browser, and a server backend application that runs somewhere in the server. Okay, so we'll use or abuse, or as you like, the HTTP protocol for a different purpose in a standard way, because now everybody's doing that. So the protocol was not invented for this reason, but we are reinterpreting the semantics of the verbs, of the methods, to fit our architecture, where it's not just one browser that browses some web pages, which is the idea of the architecture in the 1995 when everything was invented, before you were born, probably. Rather than we have one application on one side and an application on the other side, and they need to collaborate over the only protocol which is universally available, which is HTTP, with all of its limitations. Okay, for example, the fact that the server cannot contact the client makes nightmares. The fact that every interaction starts from scratch, so there's no memory between this interaction, creates nightmares when you think about the application level. Oh, okay, we'll solve these nightmares one way, where there's no authentication, there's no security, okay, in HTTP protocol. Okay, we'll work around that. We are trying to work today, 2026, on a protocol that was invented in 1992, something like that, and basically unchanged since then. Okay, but I just want to say, the get method is the easy one. The client asks for a resource, a file, some data, a document from the server. And the browser is already able to use that for getting web pages, CSS files, HTML files, images, and so on. We also have a post method that the browser uses when we submit a form. When we fill a form and click on the submit button, it's a different operation. It's an operation where some information known to the browser is sent to the server. It's not a get, it's post. I posting some data to the server. This same operation is, we can use it also inside our application whenever we need to provide some data to the server. And then the HTTP protocol also defines other methods that are normally not used by the browsers in normal navigation. For example, it's the put method, which is similar to post but not the same. And there's a delete method, and so on. So we'll use this, and we see how to do that next week for implementing some commands that the client could give to the server. Okay, we don't want to go into details of the protocol. We just know that the server is able to return some information, and in some cases the server needs to, since it's implementing some operation, that operation might fail. And if it fails, the first line of the code returns an error code, a success code 200 or one some time of error code. So it's also a mechanism that we will use for our server to communicate to the client that the operation they requested failed for some reason, and so on. So we'll also use / abuse these error codes for transferring errors or exceptions from the server to the client. We are now sort of packing inside the HTTP protocol what is normal a complex interaction between two distributed applications. Okay, headers, we don't want to details. The body, we will see some headers when we talk about cookies or authentication, but not today. The body is also important because it's a block of information that can be transferred from the client to the server in the case of request. And not all type of requests request a body, or require to provide a body. For example, the get method doesn't provide any body. We just the name of the resource to get. A post or a put, okay, if I want to give you some data, where is the data? The data is in the body of the request. On the other hand, a get implies that the server is returning some data. And so the data from the server to the client will be in the response body. Okay, so depending on the type of method, the request body may be empty or not, and the response body may be empty or not. In either case, the body should be encoded in some way. If it's just a pure text, okay, or maybe we are encoding an image with some base 64 encoding for encoding into ASCII characters, something that is a binary file, or maybe we are structuring some information in terms of maybe arrays, strings, objects, and so on, serialized as a text. So the body should always be text, ASCII text, that we can encode in some way. So whenever we have a body, some content in the body, we always must declare in the corresponding headers of the request or the response the so-called content type of the body. So how is this body encoded? In which syntax? Okay. So basically, a web page would bring a content type of text HTML, but in most of the cases, the data that we are exchanging will be in a format called JSON. JSON stands for JavaScript Object Notation. It means it's a text that mimics, that copies the syntax that we use in JavaScript to present objects. So braces for objects, square brackets for arrays, quotes for strings, and so on. So we use the syntax that we use in JavaScript to describe strings, numbers, arrays, and objects, and use that as a serialization format for exchanging complex data between the client and the server without inventing any format any time. Okay, so we'll normally exchange information into this JSON format. JSON is so simple that its specification is just one page. Because it reuses actually the JavaScript syntax. Here we have a simple map that we'll bring it over next time about which methods require a body, which are not, and so on. But of course, it follows from the semantics of the method itself. Okay, so this is just the protocol. How to manage the implementation of an application following this protocol in JavaScript? Okay, we can do that with, well, there are 20 or more JavaScript libraries for implementing a web server. And one of them, maybe the most historical one, is called Express. Okay? So for installing Express, we always follow the same rule. So I created a new folder in my project. In this folder, I open a terminal. Let's go away with the Copilot stuff. And here I can initialize a project. With all the same information. Ecco, and inside this project, I just have to install the Express library. Okay, npm install Express. Okay, and it brings, of course, some hundreds of other modules. Okay. So right now I have the library that allows me to write web applications. I can create my index.js code. Okay. Remember, always try to name your code following the name that you declared in the npm init, so that you can run just with one button press. Okay, so when we run this code, we want this to behave as a web server. And we just did run with, sorry, there's a Express inside the Express library. There's an Express object, a function that creates the server itself. And the operation for starting a web server is made of just, sorry, what is the, okay, this call, create a web server, and start it, listen. No? The listen is the method on the application object that will start the web server. And we provide a port, a TCP/IP port, on which we have to listen. Of course, normally we use 3000, some number like that, for the server, and a callback. And the callback is just run when the server is started. So these two lines create an Express object and call the listen method on the object, start a web server. And this web server will actually do nothing. We will be just there and not reply to any request until we define some routes. Sorry. Some routes. So some addresses to which this web server is authorized to respond. Some requests that this server is designed to respond to. I cannot just send a request to any web server and expect it to understand it. The server should be able to respond to a query or to a command on a given address for a given method. Get slash with the method get, or with method post, and so on. Okay, so let's do that. So we first create import from import Express from Express, and then the application is just returned by the Express function. It's not a constructor function, so there's no new keyword here. And then we start the web server up to the listen, port 3000, for example, and the callback for a successful operation. Okay, it can be console.log server start. Okay, so if you run this, okay, we'll print server started, and then we'll keep running. So this is a server, it's not just a standalone application. So it will run forever until we stop it, right? Right now it'll run and do nothing because it's not responding to any request at all, okay? So for stop it, we have the Ctrl+C, or we stop it from the debugger. Okay, just to stop the execution. Otherwise, just beware, if you're running that many times, you are running many parallel instances, and then some will fail because they are trying to reuse the same TCP/IP port, and only one process can be listening on a given port. So remember to stop it. And there's something that helps us for that, which is an application which calls nodemon, and it's a simple program that monitors the files for us and is able to kill and restart the application every time we modify something. Okay, that's useful, because otherwise We run the application, they will start, and then we try to modify the code and so on. We need to stop the application, run it again, and remember to do it every time. No? So when we're debugging. So NodeMon is, in this case, I will run the application not by the debug method, unless we are trying to debug it. I will run it with NodeMon index.js, which is basically starting the program with Node.js, but then every time I modify something and I save, it will be restarted automatically. Okay, so just when you're developing, it's something that it's handy. Express doesn't have the automatic reload functionality as other frameworks do have, and in this case we are using this. So right now we can let it run also forever with NodeMon, because we will be just reloaded every time. You see that reloaded from scratch. See, the server started, is printed again. So it will actually be shut down and restarted again every time we save some file that is a part of our project. Okay, so what can we do on that? We can register some routes that respond to some requests. So the simplest one is to respond to the home page of the website. So we can register a handler for a get request, get, post or delete, get a request on the address homepage / and the argument. So the first app is the application. .get is the method that we want to respond to. The first argument is the URL, the local part of the URL that we want to respond to. And the second argument is the callback that will be called when a client will call this URL, will send an HTTP request of type get on this URL. And the callback here is a function with two arguments, which are conventionally called request and response. We abbreviate them with REQ and RES. Request and response corresponding, so these are two JavaScript objects that correspond to this request and response messages. So actually, we can imagine that from the request object, we can get all the information that was in the HTTP request we received. And in the response object, we can build the response piece by piece. So actually, request will already have all the information we need, and the response will be nearly empty, and we need to add information to it. These are two objects, not two functions. And one of the methods of the response object, for example, is the method send. Then we see all the methods will be, we see more details. Send creates, takes an object or a string and puts that in the response body and sends the response back. So we can write hello there. And the send method takes an argument, puts it into the response body, finalizes the response bodies, and sends the response back to the client and closes the connection. So send is a final method. After send, the response is already gone, so the server doesn't have anything more to do. So if I save this, the server is ready, nothing is happening. Nothing is happening because nobody is calling that method. For calling it, we can, for example, pick up a browser and write localhost 3000 / and you get a nice string of text called hello there. What happened here? See, it is no slow motion, or better in the monitor on the developer tools of the browsers. If you see it in the network panel, Okay, I will repeat this call here. Okay, from the network I see that I have a, where is that? Why don't I see it? Sorry. Okay, sorry, I had to refresh it with a, okay. In the network panel, I see all the, let me make it a bit larger if I can. Okay. I have the trace of the different requests, HTTP requests that the browser did while navigating. So if you can navigate a normal website, you will see the page full of requests. In this case, we had only one. If I click on that, I will see the structure of the request. The request was on this URL. The method was get, which is the normal method that the browser uses. The response, you see that you have the response headers and the request headers associated with this request. They were automatically added, these headers here and the requests were automatically added by the browser, by Chrome, and the response were automatically added by the server, by Express. Now they're formatted like this, but you can see them, in the raw format. This is the actual message that was sent from the browser to the server when I clicked on enter. Method, address, okay, the protocol version, and all the headers. And the response was this one, the response headers. The response body was here. Okay? The browser took the response body and did what it only knows to do, displace it in the screen. So this is what is actually, then the browser decides that he wanted to look if this website has an icon, and so it automatically requests whether to the server whether it has a 5icon.ico file, and the server returned not found. This is the default answer that Express gives for any request that doesn't have any associated handler, any route. The request was, well, give me this file, 5icon.ico. And Express told, oh, I don't have it. Okay? Because I didn't register any route with this name /5icon.ico. So the Express doesn't know what to do with that and returns an error. So a way of trying not to debug this application is try to open a browser and issue comments. Of course, the browser is only capable of giving get comments. I also use normally an extension that is called REST client, which is an extension in Visual Studio Code that allows me to enter get or post or HTTP commands by hand and run them directly without opening a browser and so on to see what is happening. And this is once installed, it's very easy to use because you just have to create a file with the extension HTTP, tests.http, and write the command that you want to get slash, for example. And you see that this text send request just appeared because this REST extension is it's monitoring the HTTP files. And if I click on send request, sorry, get HTTP localhost 3000 slash, and if I can write a send request, it will tell me in Visual Studio, it will call the requests and will show me the response. You see the response, the first line of the response, the headers of the response, and the body of the response. So it's easy for us to also to debug the code directly in VS Code. Especially, we can also issue commands which are not get or other type of methods. Okay, without going to the browser and so on. Yep. The one on the right, I just click on send request and it was opened automatically. Yep. And you can have several requests in the same file, if I remember correctly. Yeah, you just have to separate them with 3 hash signs and empty lines so that we can have different commands, and each of them has a send request button on it. And so just it's also useful because when we are debugging, we can also repeat the same URLs over and over again without going to the browser and try to fight against the browser which tries to autocomplete our addresses and so on. Okay, just for development. This REST client. There are several. This one is one of the simplest ones. I like it. Okay, so in general, what the general behavior of Express? Okay, once we define the application, we can register many route handlers with different methods of the app object, and each of them is registered on a specific path and provide a specific handler for that request. Okay, method is any of the HTTP methods. So we have app.get, app.post, app.put, app.delete, and so on. So we just specify which method we want to respond to and the path that we want to listen to, and a slash or something else. We will learn that the path can contain wildcards, can contain parameters, so that a given route can cover for different types of variants of paths, of course. And then we have the handler function, which is where the work is done. Of course, it's a callback with these 2 arguments, request and response. And these are the main attributes of request and response. You see that in request mostly we have attributes because you say it's an object which is already initialized, and so we only have to extract the information we need. For example, there's an attribute.body that contains, well, not actually the body, but a stream from which the body can be extracted. We'll see that. For extracting the body of the request when there is a body there, or a method or a query that contains everything after the question mark in the URL. So we can extract some information from the request object, from the request message through the request object. And a response is the object we are trying to create. So it has normally a set of methods for which we can, for example, we have a send method that sends a response, or end method that sends an empty response. And is just for, okay, close the connection. I don't have any data to send you. Just click send. Or .json, I'm sending you a JSON file, so some data in JSON format, so please send the data, but also set the content type to JSON. So these are the main methods just to give the response to the client. And then, of course, we can customize the headers and other details of the response. For example, we can set the status of the response with the status method. Say, okay, everything was okay, so the status by default is 200. If we want to change it, we can change the number or the value of the status code from HTTP, of course, before sending the response. Just remember that send, end, and JSON close the response. So they should be the last method that we call. And then the response is sent, and we can go do something else. Okay, so if we want, for example, maybe I want to an address where we have the user, I don't know, of the website to be returned. Okay, the current user or something like that. So of course we need a database to query the user and so on, but how can it work from the HTTP level? So we have a result, a response, a request response with a callback. Let's imagine that we have a user object, maybe with the name and the ID could be 42 or whatever. And this should come from a database. So, but some way we have some code where we are extracting some information, and the server is asking for it. The client is asking for it, okay, on a URL which is /user. This is an object, so the response can be in JSON format. Normally, when I return an object, I use the method response JSON. The method JSON takes an object in the language and serializes it into a string using this JavaScript object notation format. And let's see what happens. I get HTTP localhost 3000 user, and it returns nothing, so it's not the correct. Oh yes. Sorry. Response.json. I didn't provide the object. Sure. I was searching for something more complex. Just I forgot the argument. So in this case, you see that the body is actually this one, where every object is represented by, so it's a text serialization of a JavaScript object. It's very similar to this code, of course, but with a stricter syntax. For example, the syntax doesn't allow, requires all the property names to have proper quotes around them. Instead, in JavaScript, you can just, if you are a good identifier, you don't need quotes around them, and so on. Okay, but apart from that, it's a common format where it's automatically serialized from objects to this text syntax. Of course, in this case, the browser doesn't know what to do. Okay, it can display this. If I open this URL on the browser, of course, the browser will do the query, but it will display some text like that, okay? The body itself doesn't know what to do with that, okay? When the application calling this route, calling this API, is actually a JavaScript application, it will know what to do with this object, okay? We will never want to display it like this in the browser. Okay, so if we have to return static data, okay, it's easy. What if we want to implement something that returns from a database? But it's not much more difficult. We just have to put here inside this project some method for interacting with SQLite, to put into the project the SQLite database, and inside the implementation of these small callbacks, we just query the database. These are asynchronous methods, so we just have to call send or JSON when we have the result. Okay? We probably don't want to do the query inside this file here. No, just to have the separation, we have maybe a different file where we have all the database interaction methods, and then the HTTP server itself that only has the methods, and then calls the other functions. And then This is the basic functionality that will require us to process every request and build every response by hand, by putting together all the pieces. Actually, the good part of Express is that it's very, very extensible, with a lot of other functions that are called middlewares. What is a middleware? The idea of processing in Express is that you get a request and a response object just from the client. Then you have your callback that is the last point where it must provide a response. But in the middle, you may have various functions that can examine and modify the request and the response objects for doing some kind of processing. So when actually you get to your own callback, the request and the response objects are already being enriched in some way. They are already being processed. For what? For data validation, for parsing of strange encodings, for user checking, for the whether the user is logged in or not, for security, authentication, and something like that. So there are different middlewares that are called before your own callback on each route. Actually, what you can do in your app.get, you have the path, you have your own callback, and in the middle you can have one or more middlewares that can process the request. And these middlewares are just functions, so callbacks themselves, that have, instead of 2, 3 parameters, the request, the response, and the next object, the next function. So the middleware, the main difference between a middleware and the callback is that the callback finally calls send and JSON. The middleware calls next, saying, okay, I finished my processing, go to the next middleware, to the next one, to the next one, and finally to the user callback. So there are normal functions that can be implemented. We can put the middlewares in a specific call, or just with the use method, we can register a callback to be automatically added to every call. Let's take one very simple one. What is that? Morgan. Because what we saw here, for example, is that the server is processing some requests, but we don't see anything on the console of the server. So maybe some logging could be useful. Okay, so we can install this. Let me stop the server. Morgan, which is a middleware for logging. We import it, and we can add the logging middleware to our application with app.use, means register. Okay, let's see one step at a time. Const logger log equal to Morgan. And it says one argument that takes the type of log that you want, the format, how much detail you want. There is for developer, for example. So what we could do here is that to add log into our routes. So whenever you are processing this URL, you will also call log before your. In this case, it doesn't modify the request or the response. We will print something on the console. So if we run it again and try to call this request, the result will be the same. But on the console of the server, you see that there's a line showing that we received this get user, and we responded with 200, and it was 25 bytes, the response. If I do the get again, every time I send it, I see the server that is logging what it's doing, okay? And it's good for debugging. While if I try the other one, it will respond with hello there, but it will not log anything. because it doesn't have the middleware registered that. So a useful thing to do would be to register this middleware for everything. So it can be done with app.use registers a middleware with one or more handlers, in this case log, and of course we can remove it here because we don't want the double logging. So it will be equivalent to writing, to inserting the logger at every request, so we can now log also the user and also the / request. So by default there is no such functionality, we just have it very easily with one middleware. Another middleware that can be very basic, is already built in, is called static. So imagine you have some images or icons or whatever on your website. Theoretically, you would have to define one path, one route for each of them to be able to respond. It would be very boring just to serve a set of static files. So what the static middleware does is to automatically define a folder whose contents can be delivered automatically. So it will automatically create routes for each of the files contained in this folder, so that every user can load them. Of course, don't point them to the main root of your application, because otherwise you will be exposing your source code to everybody that wants to read it. Okay, you pick a subfolder that contains maybe images or whatever, and then can be retrieved. And it also has the name of the folder from which it can take the images, let's say, or the other assets, or possibly a URL segment on which to map this information if you want to. If you don't want to map it on the root URL, on the root of the website. This is useful if you want to publish some static content, some static website, some static part of the website. It's not very useful if we are using a server as an API server, because we won't have many chances to publish static content. And then in the logic of having an API server, of course, not all the requests are predefined. Okay, so imagine that you have many users, okay, and you want to have information about one specific user. So maybe you have something like get http /info user equal to 1. No? You can build a URL that contains some parameters. The HTTP syntax allows me to have one URL and a set of arguments separated by question mark and a set of values that we can parse. And so the server should be able to extract this information. So I register a URL called info, and then I need to extract what are the parameters for this query. And this is possible, for example, here, if you have some URL with some parameters, you normally are in the format of keyword equal to value, ampersand, other keyword equal to other value, and so on. You can extract them with 3 properties of the request object. For example, request.query will provide me with an object corresponding to these arguments. So it's automatically converted. I don't need to read the question mark, the ampersand, and to decode everything. It's already built in. And of course, since request.query is an object that represents the query, so it represents all this part here, we can also access each single property if we know what they are. For example, let's try to register a handler for this info. So app.info.get, sorry, /info. And then we have the callback, request response. Let's see the parameters, const parameters, request.query. And say and then we don't have anything to do here, for example, just so that we just close response.end. Always remember to close a route with send or end or JSON, because otherwise the client will keep waiting until the HTTP connection times out. And then we'll give an exception because we have a timeout, network timeout error. Okay? So the exchange is must always be closed with a response message, even if the response message is empty. So in this case, let me save it and see what happens if I call this URL. Okay, this is what I've been printing here on this console.log. It's an object. Null prototype means that it didn't came from a constructor function. Otherwise, here we would see the name of the constructor function. It's just a raw object, and this is the content of this object. So the string user equal to 1 has been unpacked, and I don't know if I add some other parameters, mode equal to full, for example, because maybe I want the full information about it. And okay, it's unpacked automatically. So inside my code, maybe I can make the query starting from request.query.user. That will be, in this case, 1. So we can easily extract information from the query parameters. Request.query. And use them in our code. Another method of giving information from the client to the server, especially if it's complex information, long information, or information that we don't want to show in the URL, in the browser bar, is in the body of the request, especially when we have some post or put statement, because get doesn't allow me to provide a body. So I want to send some data, save a new user, create a new user. Okay, so imagine I'm making a new API for creating a new user. So it will be something like post, HTTP, blah, 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 new user. And they want to list all the information here in the query. And so I put that into the body. So in the REST client, for building the body, we just have to put an empty line and write the body itself. So it could be an object with name. Sorry, we have double quotes. The syntax for JSON is stricter, so we need to have double quotes, not single quotes, no extra commas, and something like that. And then ID would be 42, email, and something like that. So what we can do is to register, in this case it's a post method. So for, okay, if I call this, I will get an error not found, of course, because I didn't define it. So I can define an endpoint, a route for responding to this kind of request. It will be app.post/new user. Okay, app.post/ how can we access from inside this handler the body of the request? Okay, there is a property called request.body, but it's not automatically extracted. So request.body would be, the idea is that the body of a request could also be very long. Okay, I'm uploading an image, a file, a video. So it doesn't make sense to wait until everything is loaded to call the callback. So the body normally is loaded in an asynchronous way. The body is an object that will stream the content of the body itself. Unless there are some formats that can be parsed quickly, like JSON, for example, and we have this JSON middleware that is able to do that. So normally, Express doesn't parse the content of the body. If we have the JSON middleware and the request specifies that the body is encoded in JSON, then it will be parsed. That's just it. If I try to make here a console.log of request.body, like this, and then remember to end the response. What is happening here is that undefined. The body property is undefined normally. You need special method to extract it. In the case where the body is actually a JSON fragment, first you need to declare it in the request. Application type, content type, sorry, content type, application JSON. Because otherwise the server doesn't know. And then on the server, you need to register use express.json. So it creates a middleware which is able to parse the body when the content type is JSON. So in this case, right now, if we send the request again, we see that the entire content of the body has been read and converted to a JavaScript object. Okay, will be normal for us. So returning some object from the server to the client is easy. That's just response.json. Receiving some JSON from the client to the server requires the adoption of the middleware. So this is the second type, the second method for providing information to the server. First, encoding the URL request.query. Second, put into the body, encoded in JSON format, request.body. Third method is to use parametric URLs like this. Imagine you have some library and I don't know, with some books or whatever, and we want to encode some, we'll see some general methods next week, encode some information directly into the URL. Now, this is what is called normally the REST method. The name REST comes from this kind of set of conventions. We'll spend some time on that. The idea is that we have some URLs that contain some fragments that are actually, some fragments that are fixed, and some which contains actual data. So we want the server to respond to any pattern that has users /something /books /something else. And we can do that by embedding some in the get or post or in the URL, some fields that are prefixed with a colon. So, okay, now respond not just to this string, but this set of strings where we have /users, /whatever, /books, and so on. And all these fields are extracted and put into an object which is accessible through request.params. So in this case, it could say that, again, we want to get the information about user 42 address. I don't know. We will learn some convention about this kind of URLs. Okay, now let's just focus on the mechanism. On the server side, what can we register? We can register a generic, a parameterized route, a route with parameters. Get, it's a get, where we get users slash ID slash address in this case. And then request response. You see that this ID, or if the URL matches this pattern, then the intermediate field is being extracted and put into an object called request.param. Parameters response.end. So in this case, you see that probably we should print an object containing only one field, which is 42, with the name of the object ID. So actually, the name is coming from this pattern, and the value, of course, is coming from the request. Let's see if it didn't do anything wrong. User 42 address. User without the S. Sorry. Okay, and so this we have. If I had maybe imagine different operation or different properties of this user, maybe it's address or email or something else, I could define different URLs, or just also let the second parameter to be the second fragment to be a parameter. So maybe it will be a type, whatever. And so in this case, it will extract two different parameters. It will be an object called ID 42 and type address. Yep. And then, of course, the code will need to do some operation on that, on those. Okay, so let's not make confusion. We have three ways of sending information from a client to the server. Query arguments, question mark, ampersand, it's inside request.query. Request body, normally it's in JSON, and normally it's only in post or put methods. Requires the JSON middleware, and it's inside request.body. And the third one is on URL fragments that can be given a name, and it's inside the name and a value, of course, and inside request.params. Query, params, and body, three different objects. They work the same way. At the end of the day, you have a JavaScript object with all the information that has been parsed for you. But depending on where they came from, they go into query, into body, or into param. And especially don't confuse query with param, because it's different ways of encoding the same information in the same URL. And basically that's it. So the basic mechanism of Morgan is just being able to build most of the queries. Then we'll need to go to the database and respond something. Here in the slide you find another middleware which is interesting, can be very useful. It's called Validator. Just have a look at it. It allows you to specify a set of checks on the argument. So if you want to protect a query, say, okay, I need an argument of type user, and if it's missing, I want to generate an error. Instead of doing a lot of checks, if, undefined, and so on, you just define the rule here. And then we have an object called validation result, which tells you, okay, the validation was okay or not. So it saves us a lot of time when we want to validate something, no? Because otherwise it's very boring and you always miss something. Okay, so you declare which are the rules of the arguments that you need, and they work either if these arguments are on the query or on the params or on the body. They find information where it is, and they check that it's ready and it's the right format. So I suggest you can use it in your implementation. Let's just try to put together everything into a single query that is working, actually with the database. So let me copy the database that we had before from an exercise with the promises. We have the called questions database here, and add the SQLite to this project, just to see the full, at least once, the full behavior of an API call. For example, we have one get which is users, the list of users, okay? app.get users / users. Doesn't have any argument right now, request response. And what do? We need to get a list of users from the database. So let's make another file, db.js. Okay, we don't want to mix the stuff. And so here I can put a method for getting all the users. Function get users. And here we use, of course, SQLite methods. So here we need to import SQLite from SQLite 3. And here we do all the work. This, of course, should be an asynchronous function. It returns a promise. Okay? So we write how we want it, but it must return a promise, not a value. New promise. With SQLite, it's better to build the promise by hand. Resolve, reject. And then we have all the stuff about db.n and so on. Sorry, we need to open the database. SQLite new SQLite.database called questions. And then, okay, here we can do the same stuff. Select, db.all of select all from users. And then we have the callback that takes the rows, arrow, comma, rows, and does if reject as resolve rows. Very minimal. And in the index, what I can do is now, okay, I need to export this function. Get users. And from index, I need to import get users from db, so they can call this function from there, what do you want? db.js. Okay, you are intelligent but not enough. Okay, at this point, what we can do is just to get this information. It's a promise, so maybe we want to wait for it. So const users equal to get users would be a wait. Or get user dot then, of course. Since we are using a wait, this get should be what's the problem? At the top level modules. Yeah, because I'm not inside a function, but I'm inside a callback. So this callback should be async, but it cannot be done because, okay, get doesn't want it. Sorry, let's make it with then now. Just to make it short, then we need to wrap into an async function in order to be called, in order to call the await, but I don't want to make it long. Then result will be the users. Sorry, I don't need the users here because I'm using the then. So get user gives me a promise. We extract the value from this promise, and then we return it. In the case we don't have to do any processing, we just return in the row to the client response.json users. So this is very minimal, of course, but it should work, I hope. Yep, it gives me an array of objects containing the 3 fields coming from the database. Normally, we don't just dump data from the database to the HTTP client. We do some processing, some filtering, some checking. But the basic idea is that a client needs some information or needs some operation. It creates a URL containing the request. Could be a request for information or for action. Give me something or modify something. It goes to the database on a given route. The route will check the parameters, extract the parameters, check the validity, extract the parameters, run some queries, 1, 2, 3 queries, depends, check the results, and put the results together into some JSON format and returns them back. And this over and over again for the whole life of the server. Each request will be independent from the others. Each request will be a different operation on the data. And these operations are meaningful and useful for the client application that knows what we want to do. The server is just there for letting me access the information, the data, by doing some checks, storage, and so on. Okay? So these are the basics, and next time we'll build some small application already started from this. Thank you for today.